Hello, testing. Everyone hear me okay? How's everyone doing on the second day? A bit weary from walking around, so yes, I know I am. Well, thanks for joining. Today I'm going to be talking about building digital twins with data products. So these are two, and AI, these are two kind of very things close to my heart, digital twins and obviously data products. We know data products are a hot topic, or have been for the last 4 or 5 years. Today I'm going to be talking about how we actually bind data products together as doing AI process engineering with AI native processes. So let's kick off. So what we're going to do today, going to run through. So we're going to try and couch things, make things a bit easier to comprehend. We've got these two characters called Agent Ape and Agent Dog, and anyone who knows me on LinkedIn knows I've been talking a lot about those for the last probably year or so. And we're going to talk a little bit about what an AI digital twin is. We're also going to talk about how data products fit into the whole AI digital twin paradigm. We're going to talk a little bit about how we implement them, the process, the technology. We're going to touch on agents, because we can't do anything these days without talking about agents, as we all know. And then we're going to go run through a use case and some examples, and then really talk about kind of how we enable that through the technology platform that we're talking about, something called Nebulyx.AI. And then I'll end on some lessons from the field, from actually doing these sorts of things. So, then I can take a couple of questions if that works for everyone. So, let's meet the team. Oh, work. So, that's next one. So, let's talk about digital twins. Who here knows what a digital twin is? Come across it. So in the manufacturing world, it's great to show of hands. In the manufacturing world, they're quite common. You come up with a new manufacturing process, you do a simulation of them, and more around the physical assets around that. And typically they use historical data visualization, they do things like monitoring alerts, and things like reactive maintenance is a great use case for them. So I've taken that and turned it into basically a more general business process using AI paradigm. So what we're going to talk about is basically how we do a self-learning business process that does real-time optimization and does things like autonomous decision-making using AI as native components in there. So our guide today, as I say, are going to be Agent Ape, AI native business architect. So Ape stands for AI process engineering, and Agent Dog, which is all about data object graphs, which we're going to talk a little bit about. I've had lots of questions about what a data object graph is, but I shall talk a little bit about those. And these guys are going to guide us through kind of the whole process. So as I said, Agent Ape, AI process engineering. I have lots of conversations, lots of discussions around AI and how we adopt it. But my view, and what we've been doing with a lot of customers, is really sort of looking at actual end-to-end business process engineering, reimagining business processes using AI. And what we do is basically look at an existing business process, or a new business initiative. We have this thing called the AI toolbox, which is not just generative AI, not just LLMs, which we'll talk to you about in a minute, but basically the entire toolkit of different types of analytics and AI models. And then we basically build a prototype, a digital twin of that business process using those components. And then we test it with real users and test it with real customers. And that's really, really key, and do it all very, very quickly. So this is kind of the art, what I call AI process engineering. Our second character is Agent Dog. And Agent Dog is really the core of this process. So imagine you're describing a business process as a graph, and you then can execute that process using AI. But to do that sort of bit of a deep dive, we'll go to sort of graph 101s. Obviously, who here has heard of graphs and uses graphs on a day-to-day basis? Yeah, lots of people. So we understand what a graph is. We have nodes, we have edges, we can traverse them. I've also segmented into 3 types of graphs. So there are things what I call data-orientated graphs. So I've seen lots of vendors around here and people using knowledge graphs. So this is a classic data-only graph where you have data represented in the nodes and edges, and obviously the relationships. We also have something called an execution graph. So a query plan, for instance, for a database is an execution graph. Spark, if you all know Spark and Databricks, uses a directed acyclical graph underneath it to be able to execute a business process. But a dog actually is what we call a hybrid graph. It's actually a mixture. So the nodes aren't just execution nodes like we have in the database query plan, like things like filter, join. We have nodes which are data nodes, and we have nodes which are execution nodes. So it's very kind of bringing those two things together so I actually can have an executable business process. And I'll give you an example of that in a second. So, as I said, the executable business process here is basically, if you look at each of these nodes, we've got data nodes, we've got execution nodes, they've got a metric there, we've got kind of a node which could be a graph node, we've got a node here which could be an LLM, we've got a node which could be a Monte Carlo simulation, And the idea is that, as I say, we're representing the business process of these steps for each executable and data nodes, so we can actually query them. And we can query them using things like graph query language and other kinds of languages around that. But you're trying to actually bring those things together. And what you're trying to do is actually map out an entire business process with all the right data and nodes for executing that business process together. So now we know what dogs are, we know what Agent Ape does. What are digital twins? So again, we talked about manufacturing digital twins, which are like simulations of generally physical processes. An AI digital twin is basically a simulation of a business process. It could be any business process. It could be like your customer journey. It could be doing optimizing your supply chain. It could be doing any kind of credit scoring mechanisms, that sort of stuff. But what we do is basically we use AI to generate the first business process. We then, and it's represented as a data object graph, and then we build this digital twin of that process, connect the data, put user experience on top of it, and then test it with business users, and then we iterate around. So again, we're trying to apply that kind of classic manufacturing digital twin methodology to general business processes. So the key architecture components of a digital twin, as I say, the data object graph engine is like the core of it. We've got an AI, an LLM as part of this, that's to help generate a lot of these things. We've got data products that sit underneath it, which I'll talk to you about in a minute. And we've also got this virtualized data fabric, which is really interesting, because it means we can put probes into the whole organization, extract real data, run with real data across the whole organization as part of this whole process. Because it's really, really important that you actually use real data and actually use real processes for an organization. Otherwise, it's not going to get adopted, it's not going to be real, you're not going to be able to test the feasibility or even the value around that. And at the right-hand side, what we get is basically user interfaces, which is really important when you've got business users interacting with it. You've got the actual flows, the processes and data object graphs, and you've actually got real data as a part of this. So again, it's bringing all those three things together to be able to simulate an end-to-end process with business users. And this is an example of a digital twin for agriculture. One I did a post, I think, about 2 months ago on this. So if you look at the different layers, we've got the use cases at the top, and it's always important to start with use cases. What's the output of that? We've got the graph in the middle, which actually talked about the implementation of those use cases. We've got the data product layer, and I'll talk about that in a minute, which is actually the components of there. So we've got AI components on there, we've got metrics, we've got other types of things in there. We've got the sensor layer here, which is actually recording all the data from the farms, and then obviously the physical environment. So you sort of build up this entire picture of your physical environment, but using a digital twin process. And as I say, dogs are in the middle of it. And so what does this look like? So this is actually an example using our tool, Nebulyx.AI, and this is actually how we represent a data object graph, a full business process. So you can see, we've got nodes across here, we've got some data nodes at the bottom, crops and other field input data. We've got some metrics sitting next to it, and we've got some decision models, we've got some regression models, we've got some pipelines and some decision models out the back of it. So each one of these is a component in its own right. It's basically a data product, and they all hook together through the whole business process. And you can click on any of these and actually run them, and you can actually then query the graph. But what you're trying to do is, represent the entire business process of that particular use case. And obviously, you've got a dashboard at the end of it, or other types of visualizations around that. So, data products. I talked a lot about data products, and I know there's a bit of contention still around what a data product is. And I was on a panel last night, and I think someone asked, what do you mean by a data product? What I mean by a data product is basically a business component as part of that graph. So when I talk to business people and talk to customers, basically what I'm talking about is trying to use business language. Oh, you want to be able to do a forecast of your sales numbers. Oh, that's a forecast. Or you want to be able to look at what your historical sales performance was. That's a metric. You want to be able to do a what if. That's a simulation. So I try and use the business language around those. And each one of these maps through to a data product inside the graph. And it's really nice mapping, and you're mapping it to business questions, which is really, really important. So again, this business process engineering is really kind of the core of it, and we're trying to bring it all together to do an end-to-end. And we talked about the toolbox, so obviously Gen AI has got a lot of publicity, and it's got a lot of poster child around, getting all the oxygen around marketing, but we've been using AI and advanced analytics for years, and we've always got to look for the right tool for the box, so, try to solve the problem. So we've got time series. Anyone here use profit or any kind of time series forecasting? That's a great tool, right? Regression models, we forget those. These are the backbone of credit models, classification, clustering, obviously agents, we can bring in LLMs, also simulations. So what we're trying to do is actually, when we build the business process, we're trying to use these different types of components, these different, what I call data products, to actually fit into that and right tool for the job. I'm not trying to throw it all into Copilot, because we know how that all goes all the time. But yeah, it's really important. So that's what when I talk about data product, that's what I'm talking about. And it's also to understand each of these components, what the bias is, what the source of data, how they work. We know there's a lot of problems with hallucinations in LLMs, so understanding those, so that's super, super important. So now we've talked about kind of what the core of the digital twin is. How do we implement it? So if you see my T-shirt, the same thing. So fundamentally, what we're trying to do is we're shortcutting this process of actually discovering, we're valuing, we're prioritizing, we're then prototyping, testing, improving, and that's really, really important. And then obviously we're iterating around that again and again and again. And once we've found one that works, then we can publish, and then we evolve. It's not like a one-shot thing, because obviously AI is a living, breathing. The models, they get drift, they get skew, they get biased. They constantly evolve, and so does the business. And we have this thing called ADOPT, which is basically AI, data object graph, and product thinking. And again, bringing all those sort of things together, we use data object graphs, we use AI for the whole process. The product thinking is really that data product process, where we're actually putting in data products for each of the nodes. And the way we do that, we have something called the data product pyramid. Now, some of you who follow me on LinkedIn will have seen this before. So the idea is we're trying to decompose the business problem. So don't tell me you want a dashboard or a KPI. How do you actually decompose the problem? What decision you want to make? What outcome you want to make? Oh, right, that's a decision product. So I want to understand my future sales numbers. Oh, that's an outcome. What do you need to make that? So I need to understand what my historical data is. I need to understand what the demand is, which are knowledge products. And then I need to understand things like the historical metrics. And then I need to understand what the data is. And what we do is we go through and ask these questions in sequence, get the business to really think about how to actually put this together, and that literally maps into a pyramid process. So we talked a bit about how we do existing business processes, but it's also we can do it for new ideas. And again, we use AI to do this a lot. So basically, we can have an LLM looking at data. We can actually then do things like competitor analysis, do correlation analysis, that kind of stuff, and it will come up with ideas. And this actually has worked in a few places where we've come up and say, have you tried this new product in this particular region, because we think actually the demographics are really good there. So sometimes if the business is stuck for ideas, we can actually use this to accelerate. So again, we're trying to use AI across the board. And the process is exactly as I talked about. So we have a decision outcome, and each one of those questions gives rise to a data product. And what we end up with is actually this business process. They're all linked together based on these questions. So we get the business process as a matter of output and as a byproduct of the asking of the questions. And this is an example pyramid. So this is basically doing a new supply chain route. This is the one we did for the World Food Programme. So you can see at the top, we've got a new route decision product, which is actually giving out new routes for a supply chain. Underneath, we've got knowledge products, which are things like the future fleet capacity, a route simulator. There's a load of other ones in there. And what feeds into that is a bunch of metrics about needs, resource mobilization, etc., and then data feeds into that. And you can see it's a hierarchy, but it actually turns into a business process. So again, you get very close to the business process very, very quickly when you're actually just asking these questions. But that's obviously one use case. How do we do that for a whole organization? So what we tend to do is go in and actually look across an entire organization, look across the domains, basically the business functions and their sub-functions, and then we basically say, well, for each one of these, what's the use case? And we go through that whole process, create the digital twin, and then that actually maps through to the entire business. And what you end up is effectively these kind of small digital twins which map out the entire business across the whole organization. Obviously, it's iterative, and it changes, and it goes step by step, but it actually gives you a full visualization of how your whole business works. So how do we actually do this in reality? So this is the tool we just launched, Nebulyx.AI. And again, we've got our Canvas questionnaire, so let me run that. Hopefully it will work. Hopefully the video will work. Yeah, there we go. So what I'm doing, I don't know if can you all see that on tool? It's a little bit hazy, but what I'm doing is actually asking the questions and going down saying, what are my key decisions? What are my outcomes? What do I need to make that decision? And then all the way down the bottom, things like where do I get the data? And I'm hitting processing, and now that's going off to the model. And what the model's doing is actually looking at the questions, understanding the domain. It's bringing in a bunch of product templates. There's about 100 of them, all the different types of components that actually need to actually build the graph. And then it's having to think about kind of what that process would look like based on the outcomes. So there's a bunch of processing happening behind the scenes. And it's looking at what the context is, what the domain is, what the type of thing. And you can see now it's actually produced our first cut of our data pyramid. So we've got a decision model at the top, we've got a regression model down the bottom, and we've got a logistic regression, we've got a couple of metrics, and we've got a bunch of data sets. So again, this is actually coming up with the first cut of the process, and the idea is here that you're actually getting your SMEs to come in and do this, and actually look and go, does this make sense? Is this actually what we need to do, actually want to build? And then we basically turn that into a canvas. And this is, our Nebulyx.AI platform. We take that pyramid, and actually then we can actually turn it into a canvas. Or we can basically say, rather than go through those questions, if the business know actually what they want to do, we can actually say, right, let's actually come up with a specific outcome. So here we've got a specific outcome where we're going, I'm a new shoe retailer. I want to be able to map my supply chain for China and Vietnam, describe what data you want, and again, this is doing the same sort of thing. So rather than taking the questions, it's actually giving the specific output or outcome that you want, and again, it's having a think. It's going, right, so it's a shoe manufacturer, it's a retailer, I want to be able to optimize the supply chain, so I need to understand what the supply chain means, I need to understand what kind of products fit into that, and then I've also described what data we typically need for it, so it's going in, and what's come at the bottom of it is what we call this markup language, and we cut and paste that into it, and then suddenly we've got a whole business process. So we've done that in seconds, and obviously then you go in, execute these, tie up the data. So if this is wrong, you can change it. You can iterate around, and you can do this again and again and again. So it's really, really important to be able to do that. And what typically happens is the graphs that come out at the end of it typically change over time, but it allows us to go with massive acceleration. And because we've got using a markup language, we can actually do that very, very quickly. We can actually change it and iterate around on it. And once we've got it into the graph, we can query it. So we start doing what-if scenarios, which is really cool. So basically, you can say, for our supply chain, what happens if we up the order count through Vietnam? Or what happens if we want to change this particular price? What do we do? Can we actually query the graph and actually then come up with new scenarios? So we're doing this kind of what-if simulation, which is really, really powerful, but actually on your business process. And obviously, then we put metrics in there to measure the outcome, and actually then get people to actually look and see, is this feasible? Is it valuable? Does it work? But we can all do this in weeks, rather than normally this would take sort of 6 to 12 months to put together. We can also use AI to say this is how we actually query the object graph. We do a natural language query into it. We then basically do an NLP pipeline, so we then turn that natural language query into a GQL query. And we've got a custom data object graph engine that does this. And then actually gives you different scenarios. So if you know GQL, you can go in and do that yourself, or you can use the user interface to be able to do it. But it's really simple and really easy to be able to actually change and actually do these queryings around it. So that's great, but how do we get the data? We're at Big Data London, so how do we do this? So what we typically do is with the virtualization layer, we actually hook into transactional systems if we're allowed to. If we're not allowed to, we do a data dump. And we just pick out the right attributes that we need for the data. And then we push them through into the graph, into the data nodes of the graph, and then we iterate around it. We're not trying to do a big modeling exercise. We're not trying to do a big sort of central schemas or that type of stuff. We're literally just trying to pick out the data we need and continually do it into the graph. And then obviously it allows us to do querying and changing. So again, this is the digital twin rather than being a production system. Production would be different, but this is actually allowing us to be very agile, look at the data, understand the data directly at the source. Again, we call this minimal viable data. So, got to touch on agents. I'm not going to go too much into this, but fundamentally, we can actually bolt an agent straight onto that, and we're actually getting agents to query the object graph. So, one of the big problems with agents is the probabilistic nature of the decision making. If we get the agent actually to query the object graph as a tool, we can actually allow it to be probabilistic, to be deterministic, and actually be allowed to actually make those very transparent decisions. So, I'll probably leave this one for another talk, and he's probably a bit of a bigger deep dive. So, making it real. So, here's an actual use case that we did. This is an order management optimization, and we've done this from a diagnostic perspective. So the customer basically had orders delayed 50%, cost them 1.5 million because half of their orders were being delayed. We didn't know what was happening, so we built a digital twin based on the loss. So we actually worked out, we built some metrics, we then put a correlation product, and we put a dashboard on it, and they found out that actually one of the warehouses was actually running late, and so what we did, we then built up an inventory optimization platform. So fundamentally, we built some more metrics on it to measure that. We've got an optimization model based on in Python, and I'm using AI. And then we had a new stock warehouse plan out the back of it. So we're actually using a diagnostic process to actually come up with that. But again, the key bit is the outcome and the business process. Yep, and then obviously we showed how they reduced it down to 10% loss rather than 50% loss. So it's again a business outcome basically. What this looks like in practice. So again, it's a bit of a complex slide. So this is our digital twin platform, Nebulyx.AI. So what we've done, again, we have a data fabric built into it, hooks into the systems. We actually hook into the actual the main systems. We've got a way of generating user interfaces in there as well as part of the digital twin. And each one of these data products is effectively a microservice that gets run on a Docker container. So you can actually take the microservice and either run it yourself or actually then create a spec to actually understand what the dev and tech teams want to be able to do. Perfect. So the enabler. So obviously we look at this obviously as like the technology doesn't exist to do this. I know if I look across the floor here and see are there any vendors out there doing this kind of technology? The answer is no. So we need a different type of technology. It's not a warehouse, and it's a little bit disruptive to the data industry. But as I say, the platform that we've built to actually support this whole process, and the idea is that supporting this process is something called Nebulyx, and it has this embedded data object graph engine. It has a data products templating system, which basically allows us to deploy each one of these nodes as a separate container, basically from templates. We actually also then have a user interface component that actually marks up onto it and actually connects and actually can query the object graph in real time in using the canvas. So you need to be able to have this kind of technology to be able to do this. Obviously, you could build it yourself, which I wouldn't recommend, but this is actually something we've been doing for like 2 or 3 years, and it works very well. So obviously, if anyone wants to come and have a chat with me about this afterwards. But it is a key part of actually the whole process. So lessons from the field. So I've been doing this for probably a year or so. Been showing lots of different things, different companies. I can't stress this enough. I talked a little bit about this before. Use the right problem for the right model. So you see the previous data object graphs. We're using classic ML, classic AI. We're using sometimes metrics, sometimes decision models. Use the right tool for the job. I've seen so many people try and use an LLM for everything. We know it's biased. We know it's probabilistic. It's going to hallucinate. Understand the problem first of all. It's not, what's the LLM? If you're using an LLM, what's the problem? It's like, what's the class of problem? So are we doing a forecast? Are we doing a historical metric? What's the actual class of problem we're going to do? Understand, sometimes graph analytics is really, really useful. So understand what that's about, and also understand the environment. You don't want to go in a really complex business process if they just want a simple dashboard for understanding their historical performance. So really understanding the different components, that AI toolbox, understanding how the process works, and understanding what the class of problem you're solving is really, really important. So what happens if the data doesn't get the right information? I've seen lots of signs around saying, you've got to have AI-ready data, we've got to have foundation data. Actually, you don't in this. So fundamentally, as part of this process, you're analyzing the data with respect to your use case. And this is really, really important. Because you don't know how applicable the data is until you actually use it. So you build the graph, you build the dog, go and look at the data and say, actually, the data doesn't support this hypothesis at all. So what happens if you don't do that comes across like that? So what you can do, try another use case. Or do a cost-benefit analysis. One of my customers had 10% of their customers didn't have date of birth because they weren't around when they, back 50 years ago when they were onboarded. It wasn't a data quality issue. The business ran fine with it, but marketing needs to do a cost-benefit analysis of actually augmenting that, going out and doing surveys, contacting all those customers, what's your date of birth, that kind of stuff, but it is a cost-benefit around it. Look at other approaches. It's not all about the data. Sometimes you can use heuristics. Sometimes you balance scorecard approaches in there as well. So again, look at the right tool for the job. And also synthetic data. There are really good synthetic data tools out there to actually get you across the line to prove the digital twin. That's actually a very valid approach in a lot of cases. Obviously, we understand the limitations of synthetic data, but we'd actually use that a lot. So, just to sum up, key success factors. We are fundamentally in an experimentation age. AI is an experimentation discipline, and what we need to do is actually bring that up from just pure models into the business process, into the business process engineering. You need executive commitment, because fundamentally, if you build this wonderful process and the business don't want to change, you're going to be stuck. So really, you need a top-down, and something my good friend Eddie talked about a lot, getting the CEO, getting the C-suite buying into the business change. You've got to start with value as well. So you've got to understand what the value around it is. Is this a valuable use case? Is it going to drive revenue? Is it going to drive cost? You've got to start with that. Speed, iteration. You can't wait 12 months for this sort of stuff. Again, the platform and technology accelerates it, but it's not the end goal. The end goal is to actually get these fast iterations, test with the business. It's business transformation. Again, if you take one thing away from this talk, it's business transformation. AI is really transforming businesses. And then you need a new kind of technology, new kind of architecture. You can't just spend 12 months doing business process diagrams, build enterprise data models. This is about business use cases and the architecture to support them. Thank you. That's end of that. 5 minutes left. There we go.